and welcome to my lab, also known as my garage. So, thanks to COVID, I used to teach labs out here. I had a much different setup out here when I was out here on a regular basis teaching labs. Now, I'm not teaching labs out here, but I still have all the supplies from when I was teaching labs out here. So I thought, so while we're talking about chemical reactions, let's take a look at some actual reactions. All right, in one of these test tubes, I have a little test tube right here. Okay. All right. In this test tube right here, I've put a piece of marble, some calcium carbonate. All right. Now I'm going to take some hydrochloric acid. All right. And I am going to react this marble and this hydrochloric acid. So evidence of a chemical reaction. We might see a precipitate form. We might see bubbles. We might see a permanent color change. You won't be able to perceive a heat change if there is one, but you should be able to see bubbles and stuff like that forming. All right, so let's give this a shot. I'm sorry the lighting's not so great out here. I played with it for a little bit trying to get the best lighting that you could actually see the reactions because again, we took down my actual studio out here. So now I'm just kind of piecemealing it a little bit. All right, so here's my marble. Here's my hydrochloric acid. You can see there's a little bit of condensation that formed on the side of the tube as this started. You should be able to see the bubbles bubbling. As we react with this piece of calcium carbonate. So yes, the solid piece of marble and an acid do react with each other. And so this will keep going until the stuff in the acid is consumed, and then I would have to add more. So hopefully you can hear a little bit of that too. I don't know how sensitive the microphone on my laptop is. Okay. All right, so that's our calcium carbonate there with some hydrochloric acid. Okay, another cool one that is what we call a single replacement reaction. I'm going to take some copper 2 chloride and I'm going to put it in this test tube. Now, on the activity series, aluminum is more active than copper, which means that aluminum wants to be an ion more than copper does. So if I put some aluminum foil in this test tube of copper 2 chloride, the aluminum will start to react and it will start to dissolve into solution. And the copper will start to precipitate out as a solid. Now, the blue color of the solution is coming from the copper 2 ion. So if I added enough aluminum foil, eventually we wouldn't see the blue anymore. So let's see what happens when I add some aluminum foil. These are not the fastest reactions. Sometimes they take a little bit to get going, but this one should get going pretty soon. Oh, of course, the piece I put in here is kind of floating on top. I don't know if you can, there we go. You can sort of see it. Okay. Go. So now we're starting to get some particles floating around inside the test tube. You can see some stuff forming on the bottom. So what's happening is the aluminum is dissolving, and those particles that you see are copper precipitating out of solution. Okay. And so you can sort of see the copper color coming through. I actually tried this with more lights on and it just washed everything out. So if I come out to do more demos, I'll have to figure the lighting out again. All right, but now you can see, look at all that copper forming at the bottom. And if you look at the solution next to this, you can see that it's no longer the same blue color anymore. Okay. I'll add another piece of aluminum foil. We'll see if we can get more of it to go. Yeah, we're losing more of that blue and we're getting more of that copper forming at the bottom. So again, I can hold up the original reagent bottle definitely not the same color anymore as we've reacted that copper 2 ion, and we're now precipitating out solid copper. Okay. All right, let's see here. I'm going to use the copper 2 chloride again. I put some copper 2 chloride in my test tube. Now I have some silver nitrate. All right, so my silver nitrate will form an insoluble salt with the chloride. So silver, when it reacts with the halogen ion, so iodide, chloride, etc., it forms an insoluble salt. Okay, so here's my silver nitrate. And so we should see a solid precipitating out. There, do you see that? That white solid, that is the silver chloride. Okay. All right, so we formed some silver chloride there. This is a double displacement reaction. We can do a few more of those. Let's see here. I'm going to take some sodium hydroxide. Okay. Put that into a test tube. Okay, I'm going to add in some iron 2 sulfate. Now, when iron reacts with hydroxide ions, it forms an insoluble solid. This one's not white. This one's a little bit more colorful. So let's take a look here. You can see that dark, very dark brown precipitate forming in there. Okay. Floating around there. Okay, so that is some iron 2 hydroxide. All right, so as you can see, our evidence for chemical reaction, we're getting some permanent color changes, we're getting some gas evolution by all those bubbles coming off that we can hear. Well, again, hopefully the mic picks it up, but it's fizzing sounding, at least on my end. We're getting, white precipitate, a brown precipitate. We're getting aluminum foil dissolving into solution. Let's see here. Oh, carbonates. Those are pretty cool. Let's see here. I'll start off with there's a sodium carbonate. Put some of that in here. Okay. Okay, and now I'm going to take that copper 2 chloride again. We should get kind of a funky blue precipitate. Yeah, see, as I'm putting that in, this one, instead of being powdery, it's kind of like this gelatinous precipitate. But you can see as I shake it, there's this gunk that's sticking on the sides of the test tube. Okay, so there's another evidence for a chemical reaction. All right, and then one more. What I'm going to do now is I'm going to put some of that hydrochloric acid into a test tube. Okay, and then what I'm going to do is I'm going to add a couple of drops of something called phenolphthalein. Now, phenolphthalein is an indicator. If it is in an acidic solution or a neutral solution, phenolphthalein is neutral. So this stopper got clogged with a precipitate. I need to grab from my indicator box a new bottle of phenolphthalein indicator. There it is. So here's a new bottle of phenolphthalein. Okay, you only need a couple of drops of indicator. So I'm going to add in just a couple of drops here of my indicator. Okay. All right, now it got a little bit cloudy because this is an ethanol, and I did not have that much hydrochloric acid in here, and I put in a few too many drops. So I'm going to add actually a couple more drops of hydrochloric acid. Normally, when you put it in, you shouldn't see anything forming. Okay. And then as I add sodium hydroxide, we're going to take an acidic solution and turn it basic and see if we can get this to turn pink with the phenolphthalein. Yeah, there we go. So as I'm adding the sodium hydroxide, it starts to turn pink, but then as I shake it, it goes away because there's still acid in there. And we're still going to see the colorless solution until we get to a point where enough base is in there that now it's basic. All right. Oh, still need to add some more. Got it yet? Almost there. Oh, not quite. It went away again. Let's add a little bit more. All right, there we go. Now it's not going away. So this time, in order to see our reaction, because no precipitate formed here, when I react hydrochloric acid and sodium hydroxide, what I'm forming is a soluble salt of sodium chloride, hydrochloric acid, and sodium hydroxide. So table salt, sodium chloride, we know it dissolves. So I'm forming that soluble salt there, but I'm also forming water. So neither of those things really shows up when I do the reaction. I could pour them together and it might look like absolutely nothing happened. So I put the indicator in there so that we can see that something is indeed happening. In fact, let me grab one more test tube. Oh, and let me grab a different kind of indicator. There we go. So I'm going to grab something called universal indicator. So universal indicator is actually supposed to go through a little bit more of a series of color changes as the pH changes. So add in some more hydrochloric acid. So sometimes our evidence for a chemical change, we can't really see it. And so we have to do something else, like add an indicator in order to see that evidence of a chemical change. Okay, so I've added my universal indicator. Ironically enough, it's red, even though it's acidic. Different indicators indicate different colors. So I'm gonna grab my sodium hydroxide again. Now let's see if we can't get this to change colors as we change. Okay, so, oh, is that a different color than it was before? Yeah. So now I've changed the pH by adding the base to it. And so I can get it to change color based on the pH of the solution. So anyway, hopefully this helps you understand kind of a visual behind evidence for a chemical reaction a little bit better than just looking at pictures on a slide. And hopefully I'll come out here and, do some more demos, and maybe I'll fix the lighting out here if I can figure out what we did with the lighting. Okay, apparently my laptop does not like my glove. Something dripped on my laptop.